All right, welcome to week 5 of PLC fundamentals. Yeah, it's been a wild ride so far. Let's get into it. So this week we're going to cover um, what is a safety PLC, the difference between SIL2 and SIL3 safety categories, the what programming areas of safety PLCs are certified as safe, and then how to flash new firmware to a PLC. Has anybody here ever worked with safety equipment when dealing with SIL? Does anybody know what that is? Tatiana is writing acrylic. Yes, you've worked with it before?
Yes, I'm working with safety PLCs and with safety devices too.
Yeah, so they are, when you get dealing with them, they are a whole different level of automation. So
Oh yeah.
when people are talking about safety equipment, we're getting into oil and gas, we're getting into refineries, we're getting into systems that need to be 99.999% up, that can't fail. And if there is ever a failure of the software, it needs to alert and halt the system in a very controlled manner. So there's a lot involved with anything SIL. Because of that, the stuff that I've worked with has either been in labs or has been, to be honest, safety PLCs purchased for a system that didn't necessarily require it. So a lot of the time you'll get engineers or engineering managers who will buy safety equipment because a salesperson sold it to them, because they're very expensive. But yeah, they are. They're something that is a different stratosphere when it comes to controls. And we're gonna briefly touch on them this week. And this is by no means a comprehensive understanding of the differences of SILs, because there are specialty controllers in safety that could be hundreds of thousands of dollars for a very specific application. Sorry, I'm just adding the people who are sliding in here. Okay. So safety PLCs. So there's a quote here from Roy Tanner, the marketing manager at ABB. A safety PLC is safe when it has a certain level of reliability, programmability of failure upon demand that can be proven, documented diagnostics coverage that detect various aspects of the hardware status and programming execution and operating status, system status. That is a very complicated way of saying the safety PLCs are specialty equipment that you program. They do a lot of the same things, especially the guard logic. A lot of this presentation is specific for the guard logics platform because it's Allen Bradley. But you have a PLC which can gather diagnostic data that is there's a where the probability of a catastrophic failure is proven, and it can detect and record various aspects of hardware and program faults and operating system faults. So when the probability of a catastrophic failure, so this is typically going to be loss of life catastrophes, explosions, the supplying of, well, again, oil and gas pipelines, refineries that have very specific flow controls, or storage centers, even what some water treatment plants, depending on the size, the transport of water long distances to make sure that everything lines up. Mining uses a lot of these, where a problem with the code or interference with the code can cause big problems. These safety systems, if anybody here has been paying attention to cybersecurity risks, these safety systems are becoming targeted pieces of equipment in industry, because to affect them can cause such catastrophes. I can't think of the name of the plant, but there was an attack done where they actually managed to remotely update the firmware of the particular piece of equipment, and then that caused the whole plant to shut down in an uncontrolled way. And the oil and gas, I believe it was in not Syria, it could have been Abu Dhabi, but it was a huge production plant was offline for weeks, I believe it was. I'm gonna try to look that up, and I'll see if I can send you guys the after report. But yeah, they attacked the safety equipment, and because everybody believed the safety equipment was infallible, it got missed. And I don't remember if there was loss of life in that one. So a common safety PLC that you'll see in North America is Guard Logic's, the PLC. That's these red ones. Anything from Allen Bradley that has that particular shade of red is going to be safety. It will comply with SIL. Sorry, I'm just letting some more people in. So all of those red ones will comply with SIL requirements, which we're going to explain what SIL means in a minute. But other manufacturers, Siemens has safety equipment. There's specific safety equipment from other manufacturers that do very process specific tasks. Yeah, so again, the safety equipment is specific to the SIL categories and how they relate to safety PLCs. So SIL. So the SIL, the safety integrity level, is based on the maximum probability of dangerous failure and the minimum safe failure. So you don't need to memorize these tables, but you do need to know that every step up in SIL is 10 times more. So that an SIL2 is 10 times less safe or 10 times less robust than an SIL3. SIL3 is 10 times less robust than an SIL4. And these SIL integrity levels, the requirement of that SIL level is going to be determined on your process, how catastrophic a failure could be, the potential of that failure. So, and then the more safe you need, the more almost always, the higher the SIL, the higher the cost for the equipment and the setup and the engineering of it. So the higher SIL denotes the robustness of the device. Any questions? Again, this is very, if this seems very vague and very high level, it is. So the GuardLogix PLC has a main processor, and this processor is programmed almost the same as any of your other ControlLogix processors. But the thing that makes it special is it has a safety co-processor. So like we mentioned on one of the previous slides, where you get into safety is where you know there can be a catastrophic failure. Your equipment has to be able to automate it, but it also has to have some sort of way of kind of data checking itself, making sure that the hardware configurations are valid. There's no hardware issues, making sure the software is valid. So how is the GuardLogix more safe? It uses this co-processor, its safety partner, which is exclusive to the GuardLogix platform, to fact check the safety task inside the controller. So you'll remember where we were setting up multiple tasks. So you can have your main task, you can set up periodic tasks inside the Logix 5000 environment. With a safety controller, you can set up a safety task. So the safety, there's a secured portion of memory that stores this safety task. The safety task has its own routine, its own fault routine, its own subroutines, just like the other processors, the other routines that you can have in any other ControlLogix or CompactLogix. It's just that the safety one has a co-processor to go with it. And then the safety task will be programmed to contain the devices that require the higher safety items. Does that make sense? Just looking at the chat, giving people some time. Okay, right. The GuardLogix PLC, the safety task of the GuardLogix PLC is the only area of the PLC that would be certified SIL3. The rest of the tasks of the GuardLogix are SIL2 certified, so 10 times less robust. And anything inside that safety task is SIL3. I don't know if somebody's going to ask. I don't know if they make one that's SIL4. Again, I have not delved too much with safety just because the industries that I've worked in have not required the safety controllers. So if you're programming a GuardLogix PLC and you're installing a piece of equipment that needs higher protection of robustness, you need to locate the programming of that equipment in the safety task. So this is a screenshot of the Logix environment, and you can see the safety task that I was mentioning. So we've got the main task above it, the safety task below it. It has its own safety program, so you can have additional programs inside of it. Let's say you have multiple pieces of equipment and you have routines for safety blow-off valves, safety flow meters, safety pressure analyzers, safety pumps, safety ventilation systems. You can have different safety programs inside your safety task, but they only meet the higher safety requirement inside the safety task. So it contains its own parameters, local parameters, and its own main routine. You do have access to controller tags inside the safety program, but best practices for your safety programming is to keep all of the safety programs and parameters inside the safety task. So, small exercise, which task is SIL3 certified, A or B? Answer in your head or out loud or in chat. You answered B. You are correct. There you go. Nailed it. Thank you, Baruch. So it seems simple. At the same time, it might seem confusing why you would need this. If you end up working in an industry that requires it, you will know. And there are special ways to program. There's special hardware. There's also safety IO racks. So if you have a GuardLogix controller, the main processor will scan everything. So it'll run just like the normal processor. It'll do its main task. If you've got periodic tasks, it'll do those. And then it'll do the safety task, just like the normal PLCs. But the coprocessor rescans the safety task. And so it's going to make sure that all of the logic agrees. So if the main processor runs through a scan and it were to calculate that a specific device is supposed to be open or a specific output should be on, but then the safety processor, its coprocessor, runs through the same logic, evaluating the same IO, and finds that it doesn't agree, it will major fault the whole system, and then the fault routine will shut down in the most controlled way programmed into the system. So the PLC will go into major fault also if the safety, the coprocessor and the main processor lose comms for whatever reason. This is going to be if one gets pulled out of the rack, if the back plane fails. You can set these up where you have them in multiple racks, although I don't know why you would. You're just asking for an additional level of failure. And again, like I was saying, if there's a discrepancy between what the main processor feels the program should be doing with the logic and what the processor calculates as it goes through the same information available in the IO. If they don't match in any way, it's going to fault the processor. The other thing to be aware of is if you see a safety processor and you do not have the logic for it, there's a very good chance you won't be able to upload it. So the safety stuff will have, typically will have additional security, and then they will cross-check. So that coprocessor is going to make sure that the program in the main processor hasn't been changed. So I've heard of people going online with the normal processor, making an edit and faulting the whole thing just by starting a rung edit because they hadn't enabled the system for online edits. We don't have safety processors to really demonstrate this, especially in the online environment. The simulation emulators don't do it, but the program from last week, these simulation processors, I believe is configured to run as a safety PLC, or is configured as a safety PLC. I am incorrect. One of them was a safety PLC. I'm sorry about that aside. So again, pretty brief with the safety stuff. Safety PLCs are more robust, safer. There's less of a chance of dangerous failure, as long as the system, this is a huge caveat, as long as the system is designed and spec'd properly. So there is a whole class of engineers who specify and focus on safety systems. And if you end up in nuclear power, you end up in oil and gas, you'll find these specialists specific for the different sites. And there are guys who specialize in rigs. There are guys who specialize in fracking. All of them have their own risks. Everything has to be evaluated. There's weeks of engineering before they deploy some of these. And then the system has to be programmed in a certain way in order for it to be safer. You can't, if you were to just buy both of these, and this is one of the things that I've seen is an engineer will spec that it has to be safety because there's a machine cell and they believe that safety means if one of the gates, if one of the gate switch is open, that they need a safety PLC to shut the system down. Can you program a safety PLC to do that? Yes. Is it necessary to put the extra money in? It depends on where you want to put your budget, but you don't necessarily need it for interlocking systems. You can do that with safety e-stops, safety motor controllers, without spending $40,000 or $50,000 on these processors. Some of them are more, I believe. And then with the SIL, the safety integrity level certification, SIL3 is 10 times safer than SIL2. SIL2, 10 times safer than SIL1. Any questions on SIL? Guard logics. Has anybody dealt with, seen these? No. Yeah. I haven't seen them very much. Really good to know that they exist, and if you see them, not to play with them because they can. Yeah, a bit of SIL and process safety. Yeah, you'll see a lot of SIL engineering reports. They'll typically come in for whether it's a welding line or robotic pick and place machines. You'll do a pre-start health and safety. Sometimes the pre-starts will have SIL reports from the process engineer. And like most of these reports I've read through end up just specifying pinch points and danger zones for robot arms. Robot arms are incredibly dangerous. Those things are so powerful. If you've ever worked around them, you know what I mean. Like they will go through gates like they don't even exist if they lose their home. So in some motion control, yes, you can justify some of the safety stuff, but if you're just opening and closing valves, turning pumps on, monitoring small pressure systems, you do have to weigh the pros and cons of going down the safety rabbit hole. Okay. So the next part of processors, which I'm sure everybody's dealt with firmware before with anything, with whether it's your phones, routers, switches, weird devices in your home. Everyone's dealt with firmware before. PLCs are no different. So when I first started working, I'm trying to remember what the firmware released for Logix 5000 was. I think it was 13. They're at 32 now. They seem to be releasing like a point something like every month, constantly changing, finding security fixes, adding features. So it's very important. If there's one thing you remember about flashing a PLC firmware, don't do it unless you have to. So it's when you receive a processor, a brand new one, it's going to come with a factory tested firmware. They used to all come with firmware 15 on them, maybe 16. They might come with 20 or newer. There are some controllers, some of the new controllers can't be downgraded past a certain level, and some of the older controllers can't be upgraded past a certain level. There are version. When I say level, I mean firmware version. That information you're going to have to look in the different manuals. There are tech notes all over Rockwell's knowledge base. But if you don't need to do it, I wouldn't. If you do it wrong, you can brick. So by brick, I mean you literally turn the controller into a paperweight or a brick. If you start the upgrade process and it doesn't finish properly, if you lose power, you can damage these controllers. It's not super common. I've only done it to about 5 and not in a long time, but some of the older ones, if you're on an older firmware and you're not going to a newer conventional one, they didn't upgrade their process has fixed and their software has fixed, but you can damage them. So the control logics PLCs, they can be flashed to many different firmwares, and then different firmwares have different advantages. The older versions, so 10, didn't allow for specific online edits. If you've ever worked with the Logix 500 platform, you'll know that there's some edits in the code you can't do online. Same with 5000. There's some things in the code you can't do online. As newer firmwares come out, they're actually allowing more and more things to be done online. You can change configurations of cards. You can edit UDTs. There's tons that you can do. There's even specific firmwares. So if you start doing redundant controllers, you have to look at putting on specific redundancy firmwares. So if you're ever going down the redundancy rabbit hole, you do have to pay attention to what controllers you have and pick the proper firmwares for the other cards that you're going to be using. And then if you're going to start the upgrade, you have to finish it. So like I said, you can render these things inoperable if something happens during the firmware upgrade. So if you can do it without, like, on a USB cable on your laptop, if that's available, do that. Over Ethernet versus over serial, if your serial cable's damaged, you just want to make sure that you're going to be able to complete it. Zero to no risk of power failure in the middle of the firmware upgrade. So because we're using the emulation software, there is no chance for us to show you how to do this. So there's some screenshots, and then I'm going to use my local VM, and I'm going to flash the firmware of this test controller I have here just so you guys can see it. It's not a hard process. It's just a nerve-wracking process. I think it's Scott is the panel builder. I'm sure you guys have to flash those controllers you get in your panel every time they come in. That's great. Flashing a controller in a panel shop, low risk. But if you need to flash a controller in the field, it's a huge pain in the butt. So when you flash a PLC, to a new firmware, you're going to launch Control Flash. That's Alan Bradley's flashing utility. It's for PLCs. It's also for any communication module that you might have. All of them, if you require different firmwares for them, are going to be flashed through this software. Again, this presentation repeats it, and the Control Flash software itself will also repeat. You need to make sure you want to do this. This isn't something that you can undo. You can reflash it, but if you don't have a copy of the software that's on that processor before you flash it, it's gone. So Control Flash will look like this. It'll launch. It'll ask, say, hey, we're gonna flash the firmware. You need to know the part number you want to flash. PLC, like I said, you can also do the network cards. You need to know the network parameters. So if there's an IP address, or if it's a serial path, or whatever other network path, you need to know where it is. It's going to first ask, what part are you going to flash? So in this example, it's doing a ControlLogix L7X. So it's an L7 something. Sorry. Once you select it, you go next. Your software will show you what revisions of the firmware you have on your PC. So this actually looks like he's the person who made this control. Yeah. So the person who made this presentation then switched to 1769 L30. So that's a ControlLogix, and the current revision of that controller is revision 30. On their machine, they only have revision 28.11 and 28.12. So in this example, the only thing that they could do would actually be downgrade the firmware from 30 to 28. Once you select the version that you want, so this screenshot is showing yet another controller, an L68 L45S, going from 20.11 to 20.12. And again, the software will ask, say, hey, the target module is about to be upgraded. You really have to be sure you want to do this. And then once you say yes and everything's confirmed, it will push the firmware out. I know that seems pretty straightforward, and it really is. The take home of firmwares is you have to want to do it. You have to have permission. You have to have a reason. Any questions? Okay. So can everybody still see this presentation? Can you see this? Did I share the screen properly? Yeah. Okay. Thank you. So, like I said, I'm going to flash the controller that I have here. So I've launched RS links on my home network, and I'm going to flash this controller. So it's an L61. It currently has extrude D on it. So one of the things that you can do in RS links, and you can see here when I navigate to RS links to the IP address of the comms module, it'll actually pull up the controller and it'll show me all the different cards that are installed in this rack. So I can list the device properties, and I can see here that my ControlLogix L61B currently has 20.54 on it. So control flash comes up, looks like an interface from the 90s. It says, hey, you're gonna flash your controller. Are you sure? It is a L61. So I say, yep. And then it wants to know where it is, because you could have multiple ones. So I know mine's on my home Ethernet network. It's my control logics at that address, and that is my processor. You have to go through that. You can have multiple processors in a control logics rack, so you have to know which one you want. I select yes. So this is automatically showing me it'll automatically show you the upgraded versions of the firmware you can install. You can select show all revisions, and it will show all of the old ones too. So it looks like my VM goes all the way back to 12, good Lord, and goes up to 20. So I'm not certain if this controller, I'd have to look it up. This L61 controller might not support firmware versions higher than 20. So I might actually have firmware, because 20 doesn't make sense to be the latest, because I think I have 30 installed on here. So I'm going to assume that one of the limitations of this L61 is it can't go higher than version 20. So that means if you find an operating system, or you find a control system with one of these processors, and let's say you wanted to read from it from a brand new piece of software, well, that brand new piece of software might not be able to communicate with an old firmware. So you might need to upgrade the firmware to a newer version of it. Well, now if you've got an L61 in the field and you can't come to version 28, now you got to get a new controller. It is a huge pain in the butt. And if you had quoted your customer, yeah, I can come in and flash the firmware of that controller, no problem. It'll be a day's labor to come out and flash it. Well, then you show up and you find out, oh, well, yeah, you can't flash it because it's an old controller. It can't take the new one. Sorry, your $700 for a day's work is actually going to be $15,000 for a new controller. You really got to pay attention to that. So we'll select 19. So the target module is about to be upgraded. Are you sure you want to do this? Yeah. Are you sure you want to do this? You really got to be sure. And then it'll start transmitting data. I say, yeah, there it goes. So it'll send a number of blocks. So I believe, I'd have to look this up, but I believe the first thing that it does is it sends the new firmware pack to the controller. Once the controller then confirms it has the new firmware pack, it's going to shut itself down. So you will lose communications with the controller. First time that happened to me, I lost my mind. It will come back. It should, knock on wood, come back. The control logics typically do, because you're not flashing the comms module because you connect through a different communications module. So the unit will power off, and then it's going to load the new firmware on it, and then you're going to send more information to it. I'm just watching it there. There, that was pretty quick. So now, yes, I want to end that. When I click on my home network, actually, I'm gonna refresh that, I now have a controller with version 19, but I no longer have that program. That program that was on there has been wiped out. So if you ever do that, you need to make sure you have that new software. And if you ever need to step backwards in firmware, you can't use your program. So RS Logix is programmed that if you have a version 20 and you upgrade your software to version 22, it will move it up. It won't go backwards. So you will have issues. So this is one spot you can upgrade the firmware through Control Flash. There's another way to do that. I'll show it to you. That's fun. Huh, that's cool. When in doubt, turn everything off and back on again. Are there any questions? Well, I'm waiting for this VM to reboot. Nope. Has anybody done? So Tatiana, you said you had worked with safety controllers. What industry did you work with safety controllers in?
It's because our clients are industrial automation and we are developing controllers for them.
Okay. And is that a controller that your company makes, or is it with
Yes.
like a, yeah?
Yes. So we are doing controllers and IO devices too. And right now we are working only on safe devices and safe controllers.
No. So you're intimately familiar with all the SIL
Yes.
requirements. Oh.
Yes. So when, for example, when we get some requirements, when we are testing some requirements, those are related to SIL 1, SIL 2, SIL 3. So I've seen that before.
Oh, and it's a rabbit hole of every SIL you go up, there's just more paperwork and more proof. There's more testing.
Yes.
There's configuration. There's certifications.
Yes. We are going through the certification process for each of our devices. It's really complicated.
It's really neat. Like you really have to like. I like that stuff. I'm neurodivergent in a weird way, apparently to some people. It's really neat how intricate they can be. But yeah, that's cool. So let's see if I can launch this again. Is it gonna work? Or am I gonna get another failure? There you go. Yeah, if you ever have issues with Alan Bradley, turn your computer off. More and more integrators I find, and I've been doing it too, do a lot of their development in VMs. Do you guys use VMs for your programming? Does anybody know, or typically for wherever you're working that has the PLCs, is there like one maintenance laptop with your software? So
usually we have only software installed on some test machine and we are using it there.
Okay. Yeah. So I found somewhere about 5 years ago, as VMs became, as standard laptops became powerful enough to run virtualization software, I've found that more and more places are using VMs for programming. One of the reasons why you might not be able to is I find, like, let's say you work for you work for a foundry who has 5 different lines, and all 5 of those lines were installed by 5 different companies, and because of that, one of them's got Omron controllers, one of them's got Schneider controllers, 2 of them have Allen Bradley, and another one's got Siemens. And I don't even know if I said 5, I don't even know if that was 6. But if you have all of those different platforms, you need to have the software for all of those. So that would potentially require you to have 5 or 6 different laptops, because Allen Bradley software and Siemens software do not play well on the same machine. I've had some luck with the Omron software and the Allen Bradley software, but nowadays the best way to do it is get some VMs and spin each VM up for each different programming environment that you have. And then that way you're less likely to have issues with software is conflicting. The big issues end up being your programming software A will take control of your network card, and then programming software B can't communicate with anything. And unless you know how to disable the other software, you'll never be able to get online with your stuff. So there's a pro tip: is if you don't want to carry 8 laptops around, virtualize your programming environments. Okay, so if you come across a processor and you need to upgrade the firmware, and for whatever reason, and I'm looking at like maintenance laptops or whatnot that don't have the control flash software on there, you can actually access that here. So when you go online with the controller under Who Active through Logix 5000, you can launch the update firmware, and then this window will pop up. That says control flash. So if you have the control firmwares on your computer, it doesn't have to be in the control flash software. You can download them from Rockwell. You can access them here, and it will push it through the utility and upgrade the firmware this way without the actual control flash software. So in a pinch, I've had this work for me. I don't remember when it was added in. I believe it is version 19 and higher. It might have been version 17 that this feature in this window was added. But this is another way you can upgrade Logix 5000, Control Logix, Guard Logix, and Compact Logix firmwares. You can also upgrade the firmwares for the, like I said, the Ethernet cards if you need to. There's a little bonus, I guess, for you guys to actually see what it looks like. This is roughly how long it takes. If you had a USB, so some controllers have USB ports right in the front of them. There'll be the kind of bigger USB-B ports, like the back of your home printer or something. Typically takes a little less than over Ethernet. If you had to do it over serial, it'd take 10 times that. So that should be done. So if I go back over to, that's my daughter howling, if you can hear that. and we're back up to 20.055. So there's not a lot to flashing the firmware. You just really need to make sure you have a reason to, and you've looked into all of the repercussions of doing that. Any questions on this? All right. Okay. So that concludes my